Lousy Power Rangers. Boom! Happy Halloween, guys! Even though it's the day after Halloween. Here's my hat. Today we're going to talk about enzymes. Enzymes are organic molecules that act as catalysts. Enzymes are proteins that act much like catalysts. Catalysts speed up reactions. Enzymes are very important for cell function. So they speed up the reaction. They speed up the reactions needed, because if the reactions were slow, we'd be dead, because everything would take forever in our body, and we need reactions to speed up. Enzymes and catalysts can speed things up like by 1,000 times, let's say. And it does this by lowering the activation energy. The activation energy speeds up. The activation energy is how much energy is needed for a reaction to take place. Much like how much energy it takes to put on the shoe. So, yeah, it speeds it up. Alright, well, enzymes, what makes them unique? They're unique because they have a specific shape. So that means that they only work for one reaction. They work with that one reactant and that reactant alone. If it tried to work with something else, it would be rendered useless. Like this shoe. It's the perfect size for me. It fits me perfectly, as you saw me putting on my shoe. But this slipper, as you can see, this slipper doesn't fit me. No matter how hard I put it on, it just won't fit. See, now, let's say I got a shoe that just barely fits me. I put it on and I never take it off. Let's say in the nighttime, let's say my feet grow, but I still have the shoe on. Then my foot's gonna get stuck in that. And then I'm gonna get bunions. Nobody wants bunions because bunions hurt. If you have bunions, that means you could kiss your career goodbye. Enzymes also build things up. Much like when you put on shoes and you're working out, they also build up your muscle. Bang! Look at those legs pop. Yeah, look at those calves pop. Alright, another thing that I forgot to mention. Let's say this shoe is like an enzyme. And this space right here, it's known as an active site. What an active site is just the shape of the substrate. It allows only that certain, it's the shape of the enzyme. And it only allows that certain shape to fit in. So that shape is a substrate. So that's why it's so specific. It only has that one size. Just like a size 10 shoe only can fit a size 10 foot. Enzyme plus substrate equals enzyme substrate complex. This is how you know what it is. Enzyme substrate complex. That word is so long that it's complex. Intermolecular forces keep it together. These, let me pull them out first. These shoelaces. These keep the foot inside the shoe. That's what keeps it together. And so the substrate, what that is the reactant. It's what you add to the enzyme to make the reaction. One thing to know is that enzymes do not make reactions occur. They just speed things up. Another key thing to note is that enzymes, they don't get used up in a reaction. They can be used over and over again. Much like when we recycle. These bottles, they can be used over and over again. So recycle. Yay! It's time to play outside. Oh, there you are. So, remember how I said that enzymes have specific shapes for their specific substrates? Well, enzymes can be denatured. Denatured is when their shape changes. So, like pH and temperature, they change the shape of an enzyme. So, enzymes have specific shapes, specific temperatures, and pH, as in acidic and basic. If you were to change that, it would denature, so it would change the shape, which is not well. So think of temperature and pH differences as like bad shoes. So bad shoes means that you can't run or be as sportive as you normally would be. And I know what you're thinking, Jake Cannon, science boy, you're sexy and all, but really, these shoes, they're over the top. Yeah. Oh, you ready to see us race, right? So, another thing to add on to enzymes. Competitive inhibitors. Competitive inhibitors are substances that fit enzymes, like they fit the shape, but they're not the substrate that the enzyme is supposed to function on. So the enzyme is stuck. Try to break it down, like let's say Pac-Man lost all his teeth and he can no longer eat the ghost because the ghost is made out of titanium. So he's like chomp chomp chomp, it's not working, chomp 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 chomp. So it's stuck like that. Alright, so we're going to run from this starting point all the way to that basketball hoop over there. That's right. Coach, do the countdown.
Ready, go!
Stupid competitive inhibitor.
Yay!
Oh man. Do not tell any of your friends what just happened. I mean, oh yes. She only won by a hair, whatever you Americans call it, landslide. Now I gotta read this stupid acceptance letter. I hereby say that I lost to a 4-year-old. It's not my fault. No actors in this video were harmed in the making. Oh yeah, I guess, yeah, why not? Enzymes are proteins, but catalysts are not. Enzymes are specific for one reaction. Catalysts, they don't care. They work for everything. They're not, I don't know, reactantist, trying to say something like, you know, racist, but, you know, since they're catalysts, they're not, whatever, you get it. Enzymes work at an optimum temperature. Like, man, like when it's cold, you don't run as fast because it's cold. But catalysts, they just don't care about that either. They're like super warm, I guess. Enzymes require water because, yeah, thirsty. So I guess I'm an enzyme because I need water too. Catalysts, they do not require water. They're basically the opposite of enzymes. I don't even know how they're much alike. And enzymes and catalysts, on the bright side, do not get consumed or used up during reactions. Now it's time for my awesome dancing. Enzymes and catalysts, hoorah! Check out my awesome dancing. Peace.